So this is a simulation which is trying to simulate the use of radioactive sources in the classroom. So looking at what we have in front of us here, we have an activity meter and an event counter. Then that is connected up to this Geiger-Müller tube. And over here, we've got lots of different sources. We've got an alpha source, a beta source, and a gamma source. And then we've got lots of different materials to see whether those sources can penetrate them. So going back to this activity meter and this event counter. So you can see that this there's a little there is something happening here. Some activity is being registered, but this event counter is remaining at 0. What you need to do to actually start that event counter working is if you click on the reset button, you can see the count going up here. And essentially, it's going to count how many events are in a particular amount of time. So there is a count of 16 there. So you can see that there is this virtual equipment is simulating some kind of background activity. So this is picking up some kind of radiation, even though none of the sources are out yet. So that's a good way of introducing your students to background radiation. Background radiation is only covered at triple at the moment, but it is worth talking about background radiation because it's important for students to understand that actually radioactive materials aren't a one-off. They're not something special. They're actually very much part of our everyday life and all around us. Okay, so now what you would tend to do is you would go to one of your sources. These sources are all in lead line boxes, and you would open it and very carefully get it out, pointing towards the Geiger-Müller tube. With something, I'd recommend making sure that these sources are put nice and close to the Geiger-Müller tube, because actually alpha sources won't be able to get very far through air. So if you keep them at a constant distance from the Geiger-Müller tube, but quite close, then you can start making a comparison between the alpha, beta, and gamma. So you can see lots of activity happening here. And if we start that count going, you can see that there is lots of radiation being emitted from this source. So just waiting until that time period is through, and you can make a note. So around 73,000 counts for that particular source. If we were to try that again, but we were to take one of these materials, you can see that the count rate is a lot different. So that alpha source is being blocked by this material. If you hold your cursor over these materials, you can see you've got copper here, you've got woods, you've got aluminium, leads, glass, paper, and stone. So even if we put that back and put some paper over there, we could still see that paper is stopping a lot of that alpha radiation. Not as much as the plastic was stopping, but it's still a lot less than it was without the paper. Excellent. So you can go through all the different sources, putting them in front of the GM tube and noting the difference in radiation. You can see with this strontium, there is a lot more, this is supposed to be a beta source, and paper is not stopping this at all. We put that back and let's get some aluminium out. Let's retry that. And you can see that that has slowed that count rate right down. Excellent. So this is quite a nice, very safe type of simulation to give the students an idea of what you should expect to happen when you get these sources out, what they're stopped by, also some of the safety precautions involved. For example, there's a key here, so you can lock these away at the end of the day, which is quite nice. And there's lots of nice details, just like even switching off the equipment once you've finished with it.